Hi, and welcome to another Retronaut video. So, what are we going to do in this video? Well, in a previous video, we looked into making a BlueSCSIv2. I've actually got one here. This is an external model. And we looked at how to physically make it, how to solder it and put it all together. And in another video, we actually used it in an Ergo Pro PC from the 1990s, a Windows 98 machine. And in another video, we showed how this external SCSI device could actually plug into this GVP A500HD8 sidecar. And this is actually a SCSI-based hard drive controller. Now, inside this particular sidecar, there's actually a Zulu SCSI. That's important because this is a BlueSCSI, and as we discussed in the other video, this is a relatively new product, and it makes use of a Raspberry Pi Pico, and this particular Pico has a Wi-Fi capability, and that's what this video is basically about. The BlueSCSIv2 has the capability of actually allowing this Wi-Fi device on the Pico to actually to emulate a device from the I think it's from the 1980s, maybe the early 90s as well, called a DynaPort. So a DynaPort was a Macintosh product. It was designed to connect to earlier Macintoshes that didn't have any sort of Ethernet capability. Don't forget, this is in the days before Wi-Fi was even a thing. But the earlier Macs, people wanted to connect those, and all of those earlier Macs did actually have a SCSI port on the back, a DB25, the type that this would connect to. And that meant that those machines could actually be connected to the network using a SCSI bus, which seems a bit weird. But the SCSI bus is actually very flexible. You can connect hard drive scanners, tape drives, a number of different devices to it. And it turned out it was flexible enough actually to actually host a networking device. So Eric, the designer and engineer who produced the BlueSCSI, obviously then realized that you had this networking capability, and I'm not quite sure how it came about, but this was then realized on the Mac. What's actually happened is that people have actually worked with him to create drivers to actually work with this device, which is emulated as a networking SCSI device, and then get that to work on legacy Macintoshes as if it were a real DynaPort device. So, the DynaPort device is actually quite cool. If you look at it, it has a connection on there for SCSI, also has the proprietary Macintosh connection. I think that's, even in those days, Apple were indulging a bit of that sort of action. And you'll notice there's a little dial on there which allows you to choose which ID that particular SCSI device was going to occupy on the bus. Now, all of that stuff on the BlueSCSI is done in software. Rather, I should say, by the name of files. That's actually how you do that. So what do you actually need to actually get this to work on your Amiga? Well, number one, of course, you need an Amiga. You need to have a SCSI bus. And that means you can either have, say, for instance, a GVP. There's also a Commodore model of sidecar, which I believe is also SCSI-based as well. And I think that comes into our story later. And then there's also SCSI cards, which you can put into something like an Amiga 2000, 3000, and 4000. So if you do get a BlueSCSIv2, you can actually put that into an Amiga 500. I'm not sure about the 600 and the 1200, but at least into the 500 where, this would connect. And you can also connect it to an Amiga 2000, 3000, and 4000, which is pretty cool. So what you're getting is a replacement hard drive, and you're getting networking as an additional feature. So that makes this product even more compelling than it already was. So that's actually pretty cool. Now, for this tutorial, and I must say this is a tutorial, it's going to be quite lengthy because I've actually gone through this process with Rob. Rob is the actual guy who produced the driver, which allows you to work on the Amiga. So a massive amount of kudos goes out to him for actually getting that cat out of the bag. And, or is it in the bag? Not quite sure. He was very kind in that he gave me some of his time last evening, actually, to go through the process of getting this working. There are many steps, but it's definitely worth it, because at the end of it, you're going to have an Amiga which is networked over Wi-Fi, which is really cool, right? So yeah, you need an Amiga, you need some kind of SCSI bus, because otherwise you won't be able to use one of these. I'm going to actually connect this externally to the back of this sidecar, which if you have a look at this other video, you'll see how that works out. And I'm also going to use this to actually transfer some of the files which I need to get onto the Amiga as well. There's a driver and there's a preference file which actually needs to be transferred. So I'm going to use this to do this, which is one of the reasons why I got this external device, so I could easily do that, you know, without having to take the internal SD card out of the WluSCSI, which is actually inside here. So yeah, that's going to be pretty cool. And there is actually one more thing. You need for this, ideally, it's an optional thing, but I found it was very useful, which is a micro USB cable. Now you've got to be careful, because there are actually cables which can only supply power. And when I was originally trying to get this all working, in fact, when I was trying to flash the firmware on this device with Eric's help, Eric, the BlueSCSI guy, he explained to me that you do get sometimes probably any kind of USB cable which only can supply power. Obviously, that's not very useful when you're trying to transfer data to the device. So that's actually going to come into play in this tutorial. You need it at least to do the updating of the firmware. So you definitely need one of these. So yeah, hopefully you've got something which approximates this. You've got yourself a BlueSCSI, or you need a BlueSCSI. So you're going to get a V2, and then what you're going to do is you're going to follow this procedure and get yourself set up with networking. And at the end of this tutorial, we're going to play some music. We're going to use a piece of software called IMP3, which is an internet-based streaming music system for the Amiga. It's not really streaming, but it will actually download Amiga music modules and then play them in a sequence. And it'll just, if you leave it there, it'll just keep on downloading these modules and playing them. It's a really cool system, actually. And I've never used it before until I actually got this working. So anyway, that's enough for the whole basics. Let's get into a little bit more detail now and find out how we can get this all working. So before we go any further, I've got to show you this page. This is where the news actually broke. This is Rob Smith. And in this video, Magic Internet Access My Amiga, he explains to us how he actually managed to put together the DynaPort driver. And I'm a software engineer, and I know how arduous it can be to get these things done. But kudos to him. He's managed to get the different parts and dig up different libraries and basically hack together this driver. And it works. That's the main thing. And he's quite modest about it, but it works, and it's this working driver. So obviously in the future, there may be tweaks to it, but it's basically working right now. So in his video, he goes through the process very briefly. And that's why I felt it was important to actually go through it in detail to show you how to do it, because I actually went through this process the day before yesterday and yesterday, and it's quite involved. I think Rob would agree that. He was very kind in actually going through it in quite a lot of detail last night. So the first thing we need to do is we need to get the driver and all the other files. So if you go to this GitHub page here, by the way, I'll actually have these links on this video as well, so you don't have to go to Rob's video, although obviously I would recommend watching that one as well. So if we go to the GitHub page, you'll see that about halfway down on the right-hand side, we have the releases. So we click on that. There's only one release right now, v1.0. And it's actually at the bottom of the page where you've actually got the file to download. You just need the package.zip. And you don't need to worry about this, these docs here, because he actually includes that in the package as well. So I've downloaded that package.zip. You need to unzip that. And what we're going to do next, we're going to look at the contents of that package. So here we are. Here's the package file unzipped. There it is there. I've unzipped it. Just going to now have a look. So what have we got? Well, the first thing is Firmware UF2. And that's actually the file that we're going to use to update the firmware on our BlueSCSI. So that's obviously very important. We've got the license, which is, as far as I remember, it's a GNU General Public. So it's a public license. You've got a README text, and that's the file I was telling you about. It's got a lot of information in there. So obviously you want to open that up, have a read of it. We're going to have a read of this later because it's quite important, certain parts of it. It's well put together, good information there from Rob. Then you've got the SCSI Dana device. That's actually, I suppose, the equivalent of a driver on Windows. And we'll see later on where we actually put that on our Amiga. And then we've got the SCSI Dayna preferences as well. And that is actually detailed in his README text. He explains how to set that up, but we'll walk through that again later in the tutorial. How you get these files, it's only actually these two files that you need to get onto an Amiga. How you actually do that is up to you. I actually used my external BlueSCSI, and I took the SD card out of it, plugged it into my PC, used WinUAE to transfer the files. We actually looked at that in my previous video where we looked at actually using the external BlueSCSI device with my Amiga 500. So if you haven't watched that and you want to see how to do that, then definitely watch that video later, and it might help you if you want to use that process. I suppose it's not that likely that you have exactly that same setup, so you might want to use floppy disks, or you can use a GoTech. But for now, we need to get the firmware onto the Amiga. To do that, we have to follow a special process. So I'm going to show you how to do that. So this is my current SD card, and you can see I've got a hard drive on here, which is set to being ID 4, and I've got a log file. So with your BlueSCSI, you should find you have a log file if it's been booting. And if you open that up, you should find that at the top of it, you actually have a firmware version. And you need to take a note of that, because we're going to go through a process where we're going to update that version with Rob's version. Once we've done that, we need to come back and have a look at that version and see if it's changed. So let's do that. So once you've made a note of the version of the firmware already on your SD card, you need to put it back in. It's not actually going to be used for now, but we're just going to put it back in for later. And what we're going to do now is we're actually going to copy the firmware that Rob has supplied and put it onto our Pico. And to do that, we have to do a bit of a special process. You see here, you've actually got this button. That's actually the boot select button, and it allows you to put the Pico into a mode where you can actually see its internal storage. Not the storage, not the SD card here, but its actual built-in storage. To do this, you need to have obviously your micro USB cable plugged into your PC or Mac or Linux machine, whatever. Hold down the boot select button, and then you plug it in, and you will actually then see this device actually mount on your PC or your Mac. Then what you can do is you can actually put the firmware onto the device. So by following that process, you will find that you have a special device connected to your PC or Mac called RP2. That's actually the built-in storage in your Raspberry Pi Pico. And you can see that by default, you have an index.htm and an info.uf2 file in here. All we need to do to actually update the firmware on this device is to drag in and drop a UF2 file. So we've already seen that the package that's been provided by Rob has a firmware UF2 file in it. So what's going to happen is we're going to drop this into here. And when we do this, it's actually going to update the firmware on the device. And when it does that, it will actually disconnect the device. So it's a funny little process. It's a little bit magical, but let's do it. And we'll see it actually in action. Just going to drop the UF2 file. It's updating. And it's gone. So once you've actually updated the firmware, you then need to unplug the cable and allow it to boot off the firmware, which is now going to be used to boot up what you actually have on the SD card here. So to do that, we just need to unplug the cable, because the cable actually supplies power to our Pico. And then you plug it back in, and what you should find is that the light here will blink once, and then that's it. If it blinks 3 times, I think it is, multiple times, that means there's a problem with the boot media. And if you've actually started off with a known good setup, you shouldn't have that happen. But obviously, if there was some kind of corruption or something like that, it may happen, but it's pretty unlikely. So we're going to just plug this back in, and we'll see that light appear. There we are. There was the one blink. Did you see that? It was in green. And it's now booted up. So what that's done is it's actually used the new firmware, and you'll see that on the log file. So what we're going to do now is we're going to take this out again. We're going to put it into our PC using an SD card reader. And we're going to check what the firmware is. So now that we've flashed the firmware, we need to follow the same process as we did earlier. We just need to open up the log file again. And again, we need to go and look at the firmware version. Now, obviously, this is my working example. So in this particular firmware, there's no difference between my beginning firmware and my current firmware. I haven't actually gone through the process of using like an old firmware and then updating it with a new one. But what you should find with your SD card, obviously, is that the log on there should show a difference between your current version and the new version. So yeah, it's just a good idea to verify that that's actually worked. But flashing process, as far as I understand, is very reliable. Eric has informed me of that. So shouldn't really have any issues, but it might be useful to actually do this process just to verify that there is a change in your firmware version, before plowing onwards. Anyway, let's move on. Okay, we've updated the firmware, and that means it's actually going to work with the driver that Rob has written. And the next thing we need to do is we actually need to enable the networking device. So let's do that now. So you'll be aware that in BlueSCSI, if you watch my previous video or if you read the documentation for it, you need to use a particular type of naming of your file to actually configure the device. It's quite cool actually, because you name the files and that kind of configures everything really. It's a little bit like with Python, where, the way you do sort of indenting suggests flow. Now, on my particular SCSI setup on my Amiga 500, I have a Zulu SCSI inside the GVP sidecar, and that has, from what I recall, ID 0, 1, 2, and 3 being used. And that's why on the external BlueSCSI, I'm using HD4, which is the ID4 for my hard drive. And therefore, I'm going to use ID5 for the network device. To create a network device, you don't need any actual storage. So you don't need like a large image file like you have here. You just need to make an empty file. So on Windows, it's a little bit more complicated than it is, for instance, on Linux, where you can just type touch and then the name of the file. On Windows, you have to do a little bit of piping of data. So let's do that now. I'm just going to open up a new shell. I'm going to go to my Z directory, which is actually my flash drive, my SD card, I should say. There we are. And the command we need is basically copy null. So that's going to copy null, which I don't think actually exists. So you get basically a null value from it, ironically, and that's just going to pipe that data into this file. So it needs to be a hard file again, oddly, but this is the way that Eric has it set up on the BlueSCSI. Then you need to say it's a networking device ID5. And if we do that command, you'll see if I do a directory, there it is. There's the file NE5. And yeah, there we are. We can see it there. Now that actually says to the BlueSCSI when it's booting up that there needs to be a network device using ID5. And that's all you really need to configure it. There is a little bit more that you need to do, but we'll look at that in a second inside the BlueSCSI configuration file. But I'll actually show you what you should get if you take this SD card out, put it into your BlueSCSI device, power it up, wait for that green light to flash on the LED to show that it's actually booted. Then once it's done that, unplug the power cable, take out the SD card, put it back in your PC or your Mac, and your log file should look like this. So you can see that down here, it's opening up HD4, which is the hard drive. Then it's opening up NE5, which is the file we've just created. And it's saying it's configuring it as a network-based image, which is exactly what we want. And then talks about the ROM drive, which is actually disabled, so we'll just ignore that. When we get down to the configured SCSI devices, you can see that ID4 device is block size 512 and it's type fixed. So that's the hard drive. We did this setup in the previous video, so watch that if you need to see how that works. And then you can see that for ID5, we have a type network. So it's a network device. And that will basically, as far as I understand it, emulate the way the DynaPort system works on the Mac. So if we get a driver set up and that's enabled, we should get that device visible to the Amiga. And we're going to have a look at that in a short while. So let me just show you the INI file. There's one thing I'll actually show you first before we go on and have a look at the configuration, because at the top, you see we've got debug. It's currently set as 0. I would recommend setting it to 0 when you want to look at the SD card log, because I found that if you set it to 1, which it gives you much more detailed logging, for some reason that initial boot logout is actually less detailed. It misses out the firmware version at the top. So if you want to check the firmware version, leave it as debug 0. Maybe that's a bug that Eric might want to fix, or maybe it's intentional, I'm not sure really. But if you want to do detail logging, which we're going to do later, you want to set that to 1. If you don't set it to 1, you're going to get very, very basic logging. So definitely set it to 1, and then you'll get extremely verbose logging, and you'll actually be able to see every single SCSI activity. So the bit we're interested in actually for the network device is down here. If you add this line, and I'll just leave that on screen so you can see that clearly, Wi-Fi SSID, and then you put in your lovely password for your network, and then you put in the Wi-Fi password. In my case, these aren't real. This isn't my real SSID. So I've got my retro networky, and I've got my lovely password. If we go back to the log, it's interesting because you'll see down the bottom, it's initializing the networking device, and you can see that it's actually using that SSID. So that's it. Basically, we now have the network device set up, and it's automatically logging into our Wi-Fi network. So yeah, let's now move on to the next step. Okay, so we've got the network device made, and we've seen it working. The next thing we need to do is actually to put the drivers, preferences, etc. onto our Amiga. I'm actually going to do that on WinUAE because right now I don't have a good capture device for this screen. When I actually show you it working, we'll actually be with the real hardware, but it's just easier to show you on WinUAE because I can do screen capture there. I do plan to get a good capture device for the future. A RetroTink, I think it's 4K, but unfortunately they cost, I think, about $700. If you want to help out, please become a patron of this channel. It'd be very much appreciated. But in the meantime, I'm going to use WinUAE because it's free and it gives you very good results. So yeah, let's do that now. Let's get the machine configured and ready to rock. Right, so I've booted into the WinUAE clone of my actual physical Amiga 500. It's a fantastic feature of WinUAE, and I would definitely recommend learning how to use it because you can try out installing software before you do it on the real machine. Software installs much faster. What I've actually done in this case, I've actually given the machine a 68040 because it runs so much faster than a 68000. And that means in this tutorial, we won't have to wait around as much for the Amiga to do certain things. But obviously on the Amiga 500, in my case, it's a 68000, it will be much slower. So yeah, I mean, you can do things on the virtual machine, try it out, and then when you're happy with it, try it on the real machine. In this case, we're going to install the device driver and we're going to install the preference file for it. So let's do that now. So the first thing is we've got this data drive, and that's actually a copy of the SD card that I used to do this installation. So that's why if we open this up, we'll find the same files on it. So I've got three folders here that are actually going to be used in this tutorial. We've got networking, which we've got a bit of software in. For instance, this is where I've got Roadshow. There's Roadshow there. And then we've got package, which is where the actual drivers and so on are. And then we've got IMP3, which is a media player. It plays Amiga music modules. It's really cool. So open up package, and this is the zip file that was supplied by Rob Smith. And we've already used the Firmware UF2 file, and we've read the README text. Obviously, refer to that as you go through setting this up yourself. The first thing we want to do is we want to put SCSI Dyna device into the right location. So for that, we need to open up Workbench, and we need to open up the devs folder. And in here, there should be a networks folder, but that isn't actually created yet. If you want to install, for instance, Roadshow, it will create that folder for you and put a couple of files in there. But right now, obviously, we haven't gone through that process, so it doesn't exist yet. So we're going to just do that right now. So we're going to go new drawer, and we're going to call it networks, plural. Create that. It's going to stick it over here on the right. We're going to just put it over here. Okay, and we're just going to put that to the back, and we're going to take SCSI Dana device and drop it into the networks folder. And there it is in there. So that's it. The device driver is in place. The next thing we need to do is copy the prefs file, and then we need to edit it. I'm just going to move this down here a little bit. So that goes into the prefs folder, and I'll show you a quick thing here. Currently, I have showing all files for this folder because if you only have icons, you can't actually see the folder it needs to go into. So we need to show all files, and you'll see there's a folder in here called envarch. And if we put our preference file in there, it should end up being copied into RAM once we've rebooted. So let's do that, pop that in there. And now we just need to open that up, and we need to edit that file. So you'll see that if I double click on it, it'll actually edit the file. There we go. And a quick tip is if you go to the information of an Amiga file, you'll see that you've got the default tool here. And it's using systools text edit. So that means that if you double click on this file, it will use text edit to edit it. So let's do that. So the device, the first thing is if you're using a Commodore SCSI device, it will be called SCSI. If you're using a GVP device, it will be called GVP. So you have to work out what the actual device driver is called. There are actually other, I think, SCSI cards. I believe I have a SCSI card in my Amiga 2000. I'm not quite sure. That's a trump card, so I'm not sure what driver that uses. Possibly a different one again. So yeah, you do have to make sure that you're using the right device driver for this. Now, as I said, in my case, it's GVP. So I'm going to change it to GVP. Next, the device ID. -1 will automatically look for the network device. But in our case, we know that it's device ID number 5 because we made NE5, if you remember. Priority. This is basically a process priority, if you can imagine. If you set it to 1, it'll be high priority, 0, normal priority. Rob advised setting it to 1 if you want to get really good network throughput, but he also said it could hog the processor. I'm using a 68000. It's not a very fast processor, so we'll leave it at 0 for my case. So this here is 0 for the mode if it's a DynaPort, 1 if it's a SCSI device, and 2 if it's a GVP SCSI device. So mine is a 2, right? So I'll change that to 2. Auto-connect. Should it auto-connect to the network on boot? Let's say yes. Then you need the SSID, whatever that is. My SSID, whatever your network is called. And then my network's password. Yeah, here. Obviously, you need to put in your real SSID here and the password for it here. When you're happy with that, just go up to the menu and save. We'll just close it down and open it back up again. Just make sure that's stuck. Yep, definitely did. That's all good. And what should happen now is that if you reboot your machine, that preference file actually gets copied into RAM, and that's actually where it gets access from. And what we're actually going to do next is we're going to install the Roadshow TCP/IP stack. So yeah, let's do that now. So this is the Roadshow TCP/IP stack homepage. If we read down through the requirements, you'll see that it needs an Amiga operating system version 2.04 or higher. In my case, it's Amiga OS 3.2, so we're good. It says that it supports a SANA2 driver, and that's actually what Rob has written. SCSI Dayna device is that SANA2 driver. And I think that's it really. That's all we need to take note of here. You do need to buy this. It's not a free piece of software. There is actually a demo version, which you can try out, but unfortunately it stops working on purpose after about, I think, 10 minutes. I've already used this on my 68030 Amiga 2000. That's why I have the software. So I would definitely recommend buying this. It's a very mature TCP/IP stack. It's been around since the 1990s, as far as I understand it. It's what we're going to be using in this tutorial. So let's get it installed, shall we? Okay, so in data networking, there's Roadshow. I'm going to copy that into my C drive. And I'm going to unzip it there, or unarchive it, I should say. So LHA, extract from games C, and it's Roadshow to games C. There it goes. Takes a while. It's actually quite a big extraction, and I did this on my Amiga 500 and it took about 10 minutes. So this virtual machine's been configured to actually use a 68040, so it should actually happen quite a lot faster. Wow, yeah, really was quite a lot faster, wasn't it? So next, if we open up Game C, there's the Roadshow installation files. Open up Roadshow. We're going to install the base package first before we do anything. So let's click on Install Roadshow. We'll go for Intermediate User. Proceed with Install. Yep. Would you like to install special versions of the Roadshow BD socket library optimized for your Amiga system? I think this is because it's a 68040. So in this case, we'll say no, because for the 500 we wouldn't do that. And where do you want to install the documentation? So let's say we're going to put it in Workbench. So show drives, I'm going to put in Workbench, that's fine. And there it goes, installing. It says the installation is complete and you need to reboot your Amiga for this to work. That's fine. Roadshow can be found on Roadshow, etc., etc. The next thing we're going to do is we're going to install the update, because we obviously want it to be as up to date as possible. Update Roadshow, install for real, yes. Proceed. It's working on the installation. And it says this appears to be update. No, it's no updates are necessary. Well, that's interesting. Okay, so proceed, proceed. Okay, now if we look in the Workbench folder, and if we look in devs, as I was saying to you earlier, do you remember? Now we have a network folder, we have an internet folder, and a NetInterfaces. Yeah, so we have a few different folders now. NetInterfaces is important. All of these are actually used in this tutorial. So yeah, that's cool. Let's have a look in networks. So you can see you've got our SCSI Dyna device. It's also installed a PPP serial and Ethernet device. In NetInterfaces, we have nothing. We have to do that. And we also need to configure some of the files in here as well in internet to get this working. So the way this works is we need to set up a net interface, and for that we need to get a file from storage. So let's close this down and we'll minimize this a little bit, put this over here, open up Workbench, open up storage, and now we've got net interfaces. As you can see, that's been added by Roadshow, I believe. We need to look in there. We're going to use a device called CNET. It's not actually the web-based media program about technology. It's a network device. And I think it actually represents a PCMCIA networking card. But in this case, we're going to change it into our SCSI Dyna device. We'll just make a copy of this. Copy that. There we are. Let's probably put it at the end, isn't it? Yeah. Pop it into net interfaces. And now we need to go and edit that file. So the first thing we want to do is we want to rename it so we can know what it is. So rename, we're going to call it SCSI Dyna. There we are, so it's the SCSI Dyna device. And unfortunately, in this case, if we double click on it, let's have a look at the information on it again. The default tool for this is actually add net interfaces. So it'll try and add this network interface. So we don't want to do that. We want to edit it, right? So let's just do that using the shell. So I want to do ed workbench. I'm pressing tab because I'm using Amiga OS 3.2, so it has that ability to do tab auto completion. So it's in workbench, devs, and then it's in net interfaces, and then it's called SCSI. There we are. If we add that, we're into the file. The first thing we need to do is set the device. So it's not CNET device, it's actually SCSI Dyna device. There we are. So now it's going to use the SCSI Dyna device from the networks folder that we just added. Unit 0, we can just leave that alone. Now this is a little bit tricky. Do you want to use DHCP dynamic network addressing, or do you want to assign a manual address? Rob recommends using manual addressing because he finds that very often DHCP will time out and your network won't actually connect correctly. So we need to comment out that line, and then we need to put these in, get rid of the comments in front of them. Your router will have what's called a base address. And this looks very similar to a base address on a router. Very often routers have an IP address, a base IP address of 192.168.0.1, or sometimes it's 1 and 1. It can be different numbers, but you need to find that out about your router. So what you need to do is look at your router, work out an IP address that isn't being used. Let's imagine that, say, 183 wasn't being used, and we would use that. Obviously, if your router has this as a base address, you need to do that. So yeah, there we are. We've picked 183. Let's imagine that's going to work. And then you need to give the net mask. And again, that is discoverable from looking at your router, looking at the configuration of your Windows machine or your Mac. So you can find out those values. And I think that's it. Configure auto. Yeah, we don't want to use that. We don't want to do that. Debug, yes, that can be useful actually. So we'll just turn that on. So we'll just comment that in. I think that's it. Yeah, there's a bunch of other stuff. Yeah, so this is all good. Let's go through it again quickly. We've set up the device to use our SCSI Dana device, which is in the networks folder. And we've set the IP address that we're going to use for our network to be a valid IP address for our network, basically. And an IP address that isn't already being used. And the rest of it we can just leave as is. And as I said, just make sure that configure DHCP is off. Otherwise you may get odd results. There's one other thing. Rob recommended actually adding this line, which is a down goes offline equals yes. And what happens is that if your network goes down, it will automatically take it offline and stop having weird errors. So he recommended doing that. So let's just save that, save and exit. A quick tip here is that we don't necessarily want that device, which we just added to the network interfaces folder, to be automatically run on boot. It can be good for troubleshooting to disable that ability. So yeah, to stop that device being loaded automatically, we go into Workbench. We have to show all the files because it's actually in the S folder. Going to S, we need to find the network startup file. I believe this is a configuration file. Yep, and it's already set up to be editable. This line has been added by Roadshow, and it will automatically try to add all of the net interfaces it finds in the devs net interfaces folder. So we want to stop that because we want to do it manually. So we're just going to comment that out for now, and we're going to go save and close that down. So what we can do now is if we go to Workbench and devs, we can actually go to the net interfaces folder, double click on SCSI Dyna, and it will then try and start up the network device. And that can be useful because when you do that, you'll actually see any errors. If you don't have it do that, it will start it up when you boot up the machine and you won't see any errors. So it can be quite hard to troubleshoot. So that's why I'm recommending that for now. Okay, having done that, we'd need to do a little bit more configuration on Roadshow to get it working. So we're going to open up a shell. We're going to use ed again. So ed, devs. I'm going to use a shortcut in this case to devs. And we want to look in internet and then routes or routes, depending on how you want to say it. And I've edited that file. So now we can edit this. So what we need to do is define a default route. So as I said earlier, all routers have a default route, which is the sort of like the base IP address of that router. So we'll enter 192.168.1.1. As I said, many routers have that as their base address. Others have it as 0. Have a look at your router and see what that is, and you just enter that in here. And when you're finished, save and exit. And next, we want to edit the name resolution. So this is for when you type in a domain name, like Google, for instance, it's actually going to use this IP address to go off and convert that name into an actual IP address. So we need a name server. So you need to keep the word name server, and then you just need to change the IP address. You can see here it's using a base IP address, so that's not going to work. The Google name server is 8888. Your ISP may have a name server. There are other name servers which are available, so you can use whichever one you want. Another thing that you can do here is you can have multiple name servers if you wish. So you can obviously enable the second one, and then you can have, let's say, a different name server. And the usefulness of that is when possibly that name server's gone down, it will then fall back onto the next name server. And as you can see, you can stack up several name servers here. So I'm just going to comment that back in. I think everything's good here. Just save it out again, save and exit. And that's it. We've got Roadshow set up. So the next thing we need to do is we're going to move over to the real machine. We're going to actually use that, and we're going to see this starting up. And I'm going to also show you how to use the serial connection on the Pico to actually then see the BlueSCSI activity. And that can be really useful for debugging this. So yeah, let's do that now. So the serial terminal that we're going to use to get some debugging information from BlueSCSI is called CoolTerm or CoolTerm. I don't have any association with this. It was recommended to me by somebody on Rob's Discord. It works, and that's all I really need to do the debugging. The link for this will be in the description, so you can use this terminal. This is actually for Mac OS because I have a Mac OS laptop. Obviously, if you're on Windows, you might want to get another terminal or Linux or whatever. So let's have a quick look at it before we see what it actually does. I found it was very easy to set up. There are only just a few controls that you really need to do the debugging, really. The most important one is bottom left. You'll see that it says USB modem. Once you plug in your USB cable into your laptop and then plug that into your Pico, you'll actually see in that little drop-down menu there, you'll see a USB modem. That's actually the connection that goes to your Pico device. So you need to select that, and you possibly might need to click on connect at the top of the screen to get it to connect. Once you've done that, you will then start seeing logging from the Pico. At the top of the screen, really, we're only really worried about connecting, disconnecting if you might want to for some reason. But the cross clear is actually quite useful because when it starts logging out, it's very verbose and you'll get a lot of feedback coming back. So if you want to just wipe the slate just before you boot or something like that, just click on the clear data button and off you go. So having said all of that, let's have a quick look now at actually what it does in anger. So I'm just going to plug it into the BlueSCSI, and you'll see there we are. That's the initialization that I was telling about earlier. It's virtually the same as what you would see on the SD card after it booted, but you can see that it's using the Retronaut network that we set up in the INI file earlier. Obviously, that's not going to work. So later on in this tutorial, I'll change that over to my actual SSID so we can actually log on. But then if I then turn on the Amiga 500, which the BlueSCSI is currently plugged into, you'll start seeing more logging coming through. So there we are. Bus is reset. And any second now, boom. So yeah, you can see it's actually quite nice being able to see exactly actually what the BlueSCSI is doing. So now that we've seen that, let's actually try and get this device actually working in my real machine. Okay, so we have everything set up on my machine. So given a fair wind, this should work. So let's start off. I'm going to actually plug in the USB cable into the Pico. The reason why I'm doing this is because, as I've just shown you, it's very useful to have debugging. So I've got the terminal set up ready to actually show what's going on here. But on top of that, because this is an external device, the GVP doesn't actually have enough power to power the external BlueSCSI anyway. So you would have to plug in some kind of USB power. Anyway, let's get that plugged in. I'm going to wait for the usual single LED flash, which I've just seen there. That's working fine. So the BlueSCSI is actually ready to go. I'm going to turn on the Amiga and let it boot. We'll just wait for that to happen. It takes a while. Okay, so it's booted up. And I've got the terminal running. So if I start up the device, we should see some logging coming out. So if we go to Workbench, and as we know, NetInterface is in devs. So we open that up. There's our SCSI Dyna. And I'm going to double click on this and it should start up the network device. And let's have a look at the logging and actually see what happens when we do this. There we are, just clicked. And I'm seeing what looks like data. And I'm also seeing, it's flashing by very quickly, but I can definitely see selection 5, which is our network device. So it looks like the network device is running. How can we tell if it's actually worked just other than seeing the logging? Well, if we open up a shell, there is a command which Roadshow is installed called get net status. Let's run that. Let's just make sure I've typed that right. Yeah. And it's working. So it says network interfaces are available and configured. This would be a run of basically no if it wasn't set up correctly. No point of point-to-point networking is enabled and configured. That's because we haven't set that up. Broadcast networking is available. Name resolution is available because we set that up right earlier. And routing is available. The default route is also configured. So all of those steps that we did earlier have now paid off. Next, we're going to do a ping. And I'm actually going to ping the Google name server. because it's obviously a very easy IP address to know, to remember. And there we are. As you can see, 64 bytes are going out, and we're getting the data back, and we're getting the pings. And the pings are actually not bad. 168 milliseconds, 312 over my Wi-Fi. I'm just going to stop that and then close the shell. So next I'm going to show you what it can be used for. So in data, if you remember earlier, I showed you that inside network, just wait a second, inside networking, we have a piece of software called, actually it's not in here, it's in IMP3. It's in its own little folder. IMP3 Lahar. If you expand this file, if you decompress it, it actually is very, very bare bones. It doesn't really have much of anything with it. And if I look in here, I believe it's in store. There we are. There's the IMP3 icon. It doesn't actually have an icon. I've got show hidden at the moment, so it does need a little bit of love to make it a bit more presentable. But if I click on IMP3, it should load up IMP3 and then try and download some music and actually start playing. So let's give that a go now. It's downloaded the users on the left-hand side. All the white ones are currently online, and I think it's ready to start playing music. It does take a while sometimes to download each module, so let's click on play. It's downloading the song. Not such a big fan of that piece of music. Let's go on to the next one, shall we? Yeah, you never know what you're going to get on IMP3, I must admit. So there we go. My A500 is online. It's downloading modules live, and that's a free, basically bonus feature of the BlueSCSIv2. So there we go. I really just didn't anticipate at the beginning of this journey when I went to install this GVP sidecar with the SCSI BUS. You know, I was expecting to get a hard drive out of it. I wasn't expecting to get a network interface as well, especially on my Amiga 500, you know, a machine that was released in 1987. Yeah, it's actually pretty amazing. So it looks like the BlueSCSI is, you know, forced to stay. And there we are. It's just downloaded another song there. From what I understand, this has already been available on the Mac for a while now, this Wi-Fi capability. Don't forget the Mac was where the DaynaPort was actually produced. So it's much easier there to actually get this working. It's actually quite amazing what Rob did to get this working on the Amiga. A little bit of hackiness going on there, good hackiness. And he's managed to put together this SANA 2 driver to get this device working on the Amiga, which is really great. I can't wait to try this out actually on my big box Amigas, because in at least one of those, I have a SCSI adapter in my Amiga 2000 from what I recall. I would like to get a SCSI adapter from my Amiga 4000, but I'd actually like to get a faster one, like a SCSI 2, which would be great because that machine really would benefit from a faster SCSI device. Then I can put a BlueSCSI in it, V2, and get myself networking for free, which is really cool. There is one more feature, you know, one more thing, and that is that you can actually mount CD-ROMs, data CD-ROMs, I should point out. Phil from Phil's Computer Lab actually asked when I posted about this whether you could actually play audio CD-ROMs through this device. From what I understand, you can't do that because it's a bit complicated, but basically a CD-ROM drive is kind of like two devices. It reads the digital data, converts that into an analog signal, and that's actually an audio CD, and that's what you hear. And the rest of the data is digital, and that's just sent out in digital format to the computer. So the BlueSCSI can emulate the digital side of that, but it can't obviously do the analog side. Not sure if it could do that in the future somehow, by using the power of a Pico, maybe a future Pico, which has more power to do the digital to analog conversion, which would be involved. But it would also mean you'd have to have some kind of header on the BlueSCSI as well to actually get that analog signal out and pipe that into a PC. But definitely something which, you know, could be a future feature of the BlueSCSI, who knows. So yeah, in another video, we're going to look at the CD-ROM side of things, because unfortunately until now on the Amiga, if you did mount those CDs, the BlueSCSI, by the way, has the ability to mount multiple CD-ROM images as a single device. You could then carousel through them, but there's not actually been an interface on the Amiga to do that. So we have another contributor to the community called Paul. I'm not sure of his surname right now, but he's just released a beta of that carousel software for the Amiga. So I hope to do a follow-up video pretty soon where we look at that carousel working. I'll have to get myself some Amiga CD-ROM images because I don't actually have any of those right now. I'll get a few of those downloaded, and then we can try that out. And we should then have, for now, the full suite of capabilities on the BlueSCSI as a hard drive, as a networking device, which is really cool, and also as a CD-ROM mounting tool, which would allow you to have like 10, 20, whatever, you know, CD-ROMs and just switch through them with that piece of software, which is really great, the ability to do that. I know on the PC you have daemon tools. You don't have, as far as I'm aware, the equivalent of that on the Amiga. So you basically get that as well as part of the BlueSCSI range of features. Very, very cool. So that's it for this video. I hope you try this out yourself if you've got a BlueSCSI and an Amiga. And obviously, I'd love to hear back in the comments about what you find getting this all set up. It's a bit of a process, as you've seen. That's why I felt it was really important to actually get a video done, because I went through with this Rob interactively. Obviously, Rob's not available to everybody. I just wanted to make sure that everybody else could get this set up, because there are quite a few steps to actually get this working. But it does work. And that's the really cool thing. So yeah, if you like this video, please click on the link. That really does help the channel massively. And it'll help this video get out to other people who are interested in this fantastic tool, this wonderful device. And obviously, if you like the video, please subscribe as well, because we'd like to see you back in the future for more videos from the Retronaut. Yeah, that's it for now. And more news on the BlueSCSI very soon. As I said, follow-up video coming very soon about that. And hopefully I'll see you there. Until then, take care.